gases. So the kinetic theory states that all matter is made up of particles in motion. So the first characteristic is temperature. Temperature is a measure of the average kinetic energy of particles in matter. So if gases are heated, kinetic energy increases. And particles move faster and temperature heats up. If gases are cooled, kinetic energy decreases. Particles move slower and temperature goes down. Temperature for gases is measured in Kelvin, and the formula for Kelvin is K equals C plus 273. There's a good chance that they'll give you your temperature in degrees Celsius, and you'll have to plug that into the Kelvin formula. So the coldest temperature that matter can reach because all motion stops is at 0 Kelvin. Volume, the amount of space a gas occupies, can be measured in milliliters, liters, and centimeters cubed. Increasing the volume of the contained gas has the opposite effect. If the volume is doubled, the particles can expand into a volume that is twice the original size. With the same number of particles in twice the volume, the pressure of the gas is cut in half. So, factors affecting gas pressure. A piston can be used to force a gas in a cylinder into a smaller volume. So when the volume is increased, the pressure the gas exerts is decreased. When the volume is decreased, the pressure the gas exerts is increased. Compressibility, when you push the particles of a gas closer together. This model shows identical air samples in 2 different containers. Each container has 8 nitrogen molecules and 2 oxygen molecules. So in the larger container, to the left, the molecules are farther apart. In the smaller container, the air sample is compressed and the molecules are closer together. So fluids, anything that flows. Gases and liquids are fluids. Diffusion, so gases diffuse. And diffusion is the movement of particles from an area of higher concentration to an area of lower concentration. And effusion is the movement of gas particles through a tiny opening. Now pressure. Pressure is force per unit area, and pressure equals force divided by area. So in English, force is measured in pounds. An area is measured in inches squared. So the unit of pressure is in pounds per inches squared, or PSI, pounds per square inch. So the metric force is measured in Newton. Area is measured in meters squared. So a unit of pressure is newtons per meters squared, which is equal to a Pascal, which is abbreviated capital P lowercase a, which we'll get to in a few minutes. So, normal atmospheric or sea level is 1 atm, 1 atmosphere. And a barometer, which is over here, is an instrument that measures atmospheric pressure. So we see on top of Mount Everest is way above sea level. Now, a barometer. An atmospheric pressure pushes down on the tube, down on the mercury, and forces it up the tube. So now these conversion factors are very important, and we're going to do some pressure conversions. So we see 1 atm is equal to 14.7 pounds per square inch, which is equal to 101,325 pascals, which is equal to 101.325 kPa, kilopascals, which is equal to 760 torr, which is equal to 760 millimeters of mercury, which is also equal to 29.92 inches of mercury. So all of these values are equal to one another. So it says, convert the following pressures. A pressure gauge records a pressure of 450 kilopascals. Convert this measurement to atmospheres and millimeters of mercury. So the first one, right, like every dimensional analysis problem we've done, we're going to start with what they give us. And they give us 450 kilopascals. And I want to go to ATM, atmospheres. And I want to get rid of kPa. So what I need to do is, I need to look at these conversions I gave you right here. So I want you to look at those while we're doing this problem. So, what number corresponds with ATM? That would be the number 1. And what number corresponds with kPa? That will be 101.325. So kPa is gone. We're left in ATM, right where we want to be. So it'll be 450 divided by 101.325. And we would get 4.44 ATMs. Now the second one, we want to go to millimeters of mercury. So we have our 450 kPa. We want to go to millimeters of mercury, so mmHg over kPa again. Well, we know our kPa number, 101.325. So what's our millimeters of mercury number? If we look at that, look at our chart. And we know it's 760 millimeters of mercury. So 760 will be on top. So 450 times 760 divided by 101.325. Which would be 3,375.28 millimeters of mercury, and I'll put this in scientific notation. Or 1, 2, 3, I would have 3.38 times 10 to the third millimeters of mercury. And a manometer is an instrument used to measure the specific pressure of a gas, a specific gas. It can also be called a eudiometer. And there's two types of manometers, a closed manometer and an open manometer. And there'll be a separate video where we will do manometer calculations. So this ends our video on characteristics of gases.